Now let's change gears and talk about the liquid state. Well, sort of. What we are really going to talk about is something called the vapor pressure of a liquid. What exactly is the vapor pressure of a liquid? If you have some water in a glass and you put a lid on that glass, here is what would happen. Initially, all the space that's open without any water is empty. It's dry. It doesn't have any water vapor in it. Your liquid water will start to evaporate, and you can do this experiment at home. You can put a lid on a glass of water which contains a lot of empty space, and as the water starts to evaporate, initially what this is telling us is that water is leaving from the liquid state and entering the gas state, and that's the only thing that's happening. It symbolizes the rate of evaporation. So this long arrow means that a lot of evaporation is happening. But eventually, as your water vapor encounters this lid, it starts to condense. It has nowhere to go. It loses its energy there and it will condense. And when it starts to condense, if you were to stop this experiment at this point, you can remove the lid and see the bottom, and it will have some liquid on it, some water on it. But if we continue, what happens is the condensation rate starts to increase as more and more vapor hits your bottom portion of the lid. Eventually, the rate of condensation increases, and at one point, the rate of condensation is equal to the rate of vaporization. So, if 100 molecules of water are vaporizing at any moment, 100 molecules of water vapor are also condensing back to the liquid state. What that means is that there is no net change. We have arrived at a situation where the traffic leaving equals the traffic entering inside the liquid state, and we call that situation equilibrium. It's also called dynamic equilibrium because it's a situation where things are still changing, but there is no net change. Traffic is still moving. It hasn't become static. We haven't stopped the flow, but there is no net change. That's why it's called dynamic equilibrium. So coming back to the definition of vapor pressure. The vapor pressure is the pressure of the gas state of a liquid exerted by it in a dynamic equilibrium. So once we arrive in this situation of dynamic equilibrium, whatever is the pressure exerted by the water vapor here in this open space is going to be the vapor pressure of that liquid. Now, why do we care about covering our container, our glass of water with a lid, and letting it arrive at the equilibrium point and measuring the vapor pressure of the water vapor, or the vapor pressure of the liquid in the form of water vapor up here? Why do we care about it? Well, it has directly to do with boiling, as we will see in the next.